Okay, so this is the key to the in-class activity that we did last week. So that's where you had to use, or you had to solve a quadratic equation using substitution. And so here's the quadratic equation you had to use substitution with. Now remember, always follow directions. The directions did say use substitution. Okay, so basically what I want you to recognize is that if you look at this quadratic equation, and it is quadratic because if you take this linear expression right here and you square it, you're going to get an x squared. So when you multiply all this out, you will get x squared. So that is a quadratic equation. Now, what I want you to do though in this problem is to recognize that I have two expressions right here and right here. Those are the same. All right, so I have two expressions that are exactly the same, 3x plus 5. And this expression is being squared, and this expression is being raised to the first. So what that means is that since this expression is being squared and this expression is being raised to the first, I can make a u substitution that will make this quadratic equation so much easier to deal with. And that substitution is, and remember I did say use u, so that substitution would be I'm going to let u equal 3x plus 5. So that's my u substitution. That's my substitution. So now wherever I see the expression 3x plus 5, I'm going to substitute u. So I get 2u squared plus 5u minus 3 equals 0. So notice I went from this equation that had the variable x to this equation now that has the variable u. Make sure, because there are some students that are not careful that will put an x here. They'll say 2x squared plus 5x minus 3. Well, be careful. Those equations, if you do that, those equations are no longer equivalent because you're saying this expression that has a variable x is the same as this expression that has a variable x, and that's not true. Okay? So be careful. All right. Now, I want to factor in it. So the ones we have will be factorable. You could also solve this quadratic equation by using the quadratic formula, which we'll do because I said you did have an option at that point, but it is factorable. So if you factor this, here's what you get. You get 2u, 2 is a prime number, so that part's easy. In fact, 2 and 3 are prime numbers, so that should be easy to factor. So I get 2u and u, and then for 3, let's go ahead and put the 3 here, the 1 there, so that's where it's going to work. The last sign's negative, so remember that means that these signs in here are different. One's positive, one's negative, and the larger of the outer and the inner will take that middle sign. Well, 2 times 3 is 6, 1 times 1 is 1, so 6u is going to be positive, and 1u will have to be negative, and then that will give us our 5u. All right, so now I have two factors whose product is 0. So that means that one of those factors has to be 0, right? So either 2u minus 1 equals 0 or u plus 3 equals 0. And so now I'll solve for the variable u. So I have these two linear equations, so 2u has to equal 1, which means u has to equal 1/2. Over here, u has to equal negative 3. So I went from an equation with the variable x to an equation with the variable u, making a substitution. So now I've solved this equation. So the solutions to this equation here is 1/2 and negative 3. But that is not the solution to the original because the original had the variable x. So now you have to resubstitute. So now you're going to say, well, if u equals 1/2, then that means that 3x plus 5 has to equal 1/2. If u equals negative 3, then that means 3x plus 5 has to equal negative 3. And so now we solve these linear equations with the variable x now. So some students don't like dealing with fractions, like you would have to subtract 5 from both sides. So there are a couple ways you could do this, and I'll show it to you using, let me use this. So let me just kind of show you what you could do. So where you have that 3x plus 5 equal 1/2, one thing you can do based on what you've learned before is that since I have fractions here, let's go ahead and clear the fractions. Well, my least common denominator is 2, so I'm going to go ahead and multiply. Let me go ahead and rewrite this over. So I'm going to go ahead and multiply both sides by 2. What I do to the left, I do to the right. What I do to one side, I do to the other. And so now I'm going to go ahead and distribute. So 2 times 3x is 6x. 2 times 5 is 10 equal, and then a half times 2 is 1. So notice you now have a linear equation without any fractions in it. And so now you just go ahead and subtract 10 from both sides. You got 6x equal negative 9. 1 and negative 10 is negative 9. And then divide both sides by 6. I get, when I reduce, 6 divided by 6 is 1. 1 times x is x. So I get x to be, and then reduce this, and they're both divisible by 3. So I get negative 3 halves. All right. So that will be the solution here. Another way you could do this is actually subtract 5 from both sides, right? Subtract 5 from both sides. And when I do that, combine like terms, 5 and negative 5 is 0. So you get 3x equal. And there you got to figure this out now. So you got to say, well, I have 1 half, subtract 5, right? 5 over 1. So the least common denominator is 2, so I'm going to write 2 fractions with a denominator 2. So I've got to write equivalent fractions now. 1 half is always equivalent to itself. 5, I have a 5 here. 5 divided by 1 is equivalent to what number divided by 2? Well, that's where you're going to have to recognize, hey, I have a 1 here. I want a factor of 2. So that means I got to multiply this 1 by 2 to get a 2, right? But what I do to the denominator, I do to the numerator. 5 times 2 is 10. So, and always check yourself, 10 divided by 2 is this 5 that you want it to be equivalent to. So now I have 1 half minus 10 halves, which is a negative 9 halves, right? Negative 9 halves, right? So I get negative 9 halves right here, okay? So 1 half minus 5 is a negative 9 halves. Now what you got to remember is, hey, now I've got to go ahead and get x by itself. So now I've got to divide both sides by 3. Let me go ahead and just rewrite this over. So I got to say divide by 3, divide by 3. So 3 divided by 3 is 1. So I get 1 times x is x. But you got to remember this. I have a fraction being divided by another fraction, right? So now I got to change this division to multiplication. So that's where you take the fraction in the numerator and you multiply by the reciprocal of the denominator. Well, the reciprocal of 3 is 1/3. And then you reduce. 3 divided by 3 is 1. Negative 9 divided by 3 is a negative 3. And look what you get. You get negative 3 times 1 is a negative 3. And then 2 times 1 is 2. So notice you get the same answer regardless of which approach you took. Most students, well, I shouldn't say most, it's kind of half and half, I guess, because they recognize, hey, I'm going to go ahead and clear this fraction, and notice how easier it is by doing it this way, whereas you're going to have to be careful because there's some computation that you're going to have to do along the way if you do it this way. All right, so I'm going to go ahead and put this up here just in case you need to see this. All right, so that's another way to get this right here. Now, obviously, this was the easy one, right? There's no fractions here, so just subtract 5 from both sides, and you get 5 minus 5 is 0, so you get 3x equal 3 subtract 5 is a negative 2. Divide both sides by 3. You get x to be negative 2/3. So your solutions are x equal negative 3 halves and x equal negative 2/3. Those are your solutions. Now, I just wanted to remind you, you remember where we were at this point right here? And we said that we're going to go ahead and factor. Well, at that point, you could have also used the quadratic formula. So let me just kind of show you. So if I have 2u squared plus 5u minus 3 equals 0, I just want to show you that you will still get these two values for u using the quadratic formula. So remember the quadratic formula is the opposite of b, plus and minus the square root of b squared minus 4ac, all divided by 2a. So before we substitute numbers into the quadratic formula, let's go ahead and determine what a, b, and c are. So a is a coefficient of the squared term, which is 2 in this case. B is a coefficient of u to the first power, so that's 5. And c is your constant, which is a negative 3. Again, always make sure it's in descending order, and it's also in standard form, so you needed a 0 on that other side. So now let's go ahead and substitute. So I get, now remember this is u, not x. This is the variable u. So you got to say u equals the opposite of b. Well, b is 5. The opposite of 5 is a negative 5. Some of you, if you're not careful, you're going to put this as a 5 and you get some wrong values here. So negative 5 plus or minus the square root of b, which is 5, and I'm squaring that, minus 4 times a is 2, times c, which is negative 3. All of that, all of this is being divided by 2 times a, so 2 times 2. So I get negative 5 plus or minus the square root of 5 squared is 25. A negative 4 times 2 is 8, and a negative 8 times a negative 3 is a positive 24. So this becomes 25 plus 24, not 25 minus 24, 25 plus 24, divided by, and then 2 times 2 is 4. So that's equal to negative 5 plus or minus the square root of 25 plus 24 is 49, divided by 4. You have to recognize that 49 is a perfect square, so the square root of 49 is 7. Oops, let me do it this way. So I get negative 5 plus or minus 7 divided by 4. Now at that point, I'm going to split it apart so I can get those two rational solutions. Because remember, your rational solutions are 1/2 and negative 3. So split it apart now. So that becomes negative 5 plus 7 divided by 4, and then negative 5 minus 7 divided by 4. So negative 5 plus or minus 7 means negative 5 plus 7 and negative 5 minus 7. Negative 5 plus 7 is 2, so you get 2/4, which is reduced to 1/2. And that's one of them. Negative 5 minus 12 is minus 7 is a negative 12 divided by 4, and negative 12/4 is a negative 3. So notice this is u. So u equals 1/2, u equals negative 3. Not x, u. So it's important you recognize that that's u. And so notice that this right here, oops, this right here is this right here. Okay? So, and then the rest would be you do the substitution. Okay, so this point here, this right here, when you got to this point, you could factor. Now notice factoring makes things so much easier, right? Notice how much work was involved with using the quadratic formula. But factoring makes things so much more efficient for you to go through the process. But once you get to that point, once you find u, there's still some work you got to do because the original equation had the variable x. So you have to go back, make sure at this point you go back and you resubstitute just like we did here. I'm not going to do the rest because the rest is this right here. So you're going to say 3x plus 5 equal 1/2, and then 3x plus 5 equals negative 3, and then you continue on. All right, but that work here is the same as this. All right, now, so that was what you had to do. Okay, that was it. That is what you had to do. Now, just to remind you, remember, always follow the directions, right? So the directions said use substitution. But if the direction just said solve this quadratic equation, nothing more, just solve this quadratic equation, and it didn't tell you what method to use, I just want to show you something. So if that was the case, but remember that the directions did say use substitution. So you had to do it this way. But if the directions did not indicate how to do this, then here's another way. Now, doing it substitution makes it easier, okay? But here's the other way. So suppose you forgot about, hey, I forgot about substitution. I forgot I had learned that. Then all you have to do is do it the long way. And so you have to recognize that I've got to square. Remember, order of operations, you got to square first. So you got to square this binomial. So I'm going to go ahead and figure out what 3x plus 5 times itself is, right? And so when I multiply this out using FOIL, 3x times x, 3x is 9x squared. The outer and the inner, since I'm squaring a binomial, the outer and the inner have to be the same. So the outer is 3x times 5 is 15x. The inner has to also be 15x. And then the last, 5 times 5 is 25. Combining like terms, I get 9x squared. 15x and 15x is 30x plus 25. So that goes here. Okay? But all of this, see, that's this right here. All of that has to be multiplied by 2. So I got to say 2 times 9x squared plus 30x plus 25. and then plus, and then I'm just going to go ahead and rewrite everything over. 5 times 3x plus 5 minus 3 equals 0. And now distributing those three terms, multiplying those three terms by 2, and then multiplying those two terms by 5, here's what we get. 2 times 9x squared is 18x squared. 2 times 30x is 60x. 2 times 25 is 50. Plus 5 times 3x is 15x. 5 times 5 is 25. Minus 3 equals 0. Combining like terms, I get 18x squared. 60x and 15x is 75x. 50 plus 25 is 75. 75 minus 3 is 72. So I get a positive 72, right? So plus 72 equal 0. So that's where I'm at. So I went from this quadratic equation to this quadratic equation. But now I've got to solve this quadratic equation. Now notice, this is a little bit more difficult to factor, isn't it? That's more difficult to factor. You got to figure out what factors of 18 can I use, what factors of 72 can I use, so that way my middle term would be 75x. That's a little bit more difficult. So now at that point, since those numbers are pretty big, and you could probably reduce, let's see, all of those are divisible by 3. You see that? They're all divisible by 3. 18 is divisible by 3. 75 is divisible by 3. 72 is divisible by 3. So they're all divisible by 3. So I could reduce the coefficients at least. So what you do to one side, you do to the other. So basically what I'm saying is this. Since they're all divisible by 3, I'm going to divide both sides by 3. What you do to one side, though, you got to do to the other. And you can only do that because that's an equation. So 18 divided by 3 is 6. 75 divided by 3, if you don't know it real quick, just use your calculator. 75 divided by 3 is 3, right? Makes sense because 25 times 3 is 75. And then 72 divided by 3, what's that, 24? Equals 0. Okay? So now, that's about as far as I can go in terms of reducing. So it makes it a little bit easier to try to factor, it looks like, doesn't it? So let's see, if we try factoring 6x squared, there are two possibilities. There's 3 and 2, 6 and 1. Let's try 3 and 2. So 3x, 2x. 24, there's 12, 2, 8, 3, 24, 1. Let's use 8 and 3. Let's see, let's try putting the 8 here and the 3 here. The last sign's positive, so that means these signs have to be the same, and they're both going to be that middle sign, so they're both going to be positive. But let's double check, always double check. But you could have used a quadratic formula here or here, it does not matter. But notice it makes things a lot easier to notice that all these coefficient, that constant here are all divisible by 3. Okay, so make things a lot easier. But let's double check to make sure that this is correct. We have 3x plus 8 times 2x plus 3. And if we FOIL, 3x times 2x is 6x squared. The outer, 3x times 3 is 9x. The inner is 16x. And the last, 8 times 3 is 24. Combining like terms, I get 6x squared. 9 and 16 is 25x. 9 and 16, 9x and 16x. And then 24, and that's what you wanted. All right, so I'm going to set each fact equal to 0. 3x plus 8 equals 0. 2x plus 3 equals 0. So I'm going to solve these two linear equations. So I get 3x equal negative 8. So x is negative 8 thirds. Okay, over here, 2x equals a negative 3. So x equals negative 3 halves. And I want you to notice, let's see. All right, so I want you to notice something here. So you see how I got x to be negative 8 thirds and x to be negative 3 halves, right? Okay, so those are the solutions to those. I want you to notice something though. And I want you to notice this. Right here, they're not the same. I made a mistake, didn't I? Right here, see where I have u equals negative 3? That's why you have to be careful along the way. Here's my mistake. U equals negative 3. What did I put? A positive 3. That should be what? Negative 3. So I knew something, I knew I made a mistake originally because those two right here are not the same here. I have negative 8 thirds, negative 3 halves, but I don't have the negative 8 thirds here. So I made a mistake there. So look, this should be negative. So negative 3 and negative 5 is a negative 8, right? So I get negative 8 thirds. So that should be a negative 8 thirds right here. All right. So yeah, you can make mistakes very easily. See how easily it was to make that mistake? But if you made that mistake, see how I made that mistake, you would get most of your points because it's a mistake. We all make mistakes, right? But I mean, we want it to be correct, so we can't get all the points. But you'll get. I mean, you did a lot of work here. You made a mistake with that negative 3, um, and so you should get most of it. I'll give you most of it. You won't get all of it, but you'll get most. All right, but that's how I knew I made a mistake because when I did it this way, I got a different answer. All right, but anyway, so we figured out where the mistake is. The mistake was that when I rewrote negative 3, I didn't put the negative. Okay, so that is it. So that is the key to that in-class activity.